I would pose the question, would it necessarily be the case that we would say, with today's conception, that one can always tell whether or not one is accelerated? Simply look to see if there are inertial effects, like the sloshing of the water. So is that true? Do you think it's true? It certainly seems that's what we learned, isn't it?
Yes, I suppose, yeah.
Okay, can you think of any kind of counterexample? Like, could it possibly be? Everybody's pretty sure that that's true, that if something is uniformly moving or stationary, which is the same thing, they're in an inertial state, that there won't be any kind of inertial effects. And contrary case, if it is accelerating, there will inevitably be inertial effects. However, there is a counterexample. And that was pointed out actually by Newton and later by Maxwell. Equally accelerated forces. Imagine we're in outer space. We're very far from any kind of conceivable physical effect. We can't even see any distant galaxies. You're standing still in your frame, and this other person is moving uniformly next to you, and they expect to see no sloshing because they're moving uniformly, and you're standing still and they're uniform to you. And there's some kind of field, nevertheless, there. And it accelerates everything exactly the same way. Everything is accelerating. Things could be moving within that system in different ways. They can have different velocities. But the acceleration that they acquire as a result of the field, exactly the same. All of you and the cup and the fluid are all accelerated by this field. So if you think about it, however you're moving or not moving, your acceleration is the same as the acceleration of the cup, is the same as the acceleration of the liquid in the cup. You can see that this kind of field does not produce any inertial effects, even though the motion is accelerated. Which is kind of weird, because we always used to think that it's not true, that any accelerated motion leads to inertial effects. Is there any way that we could ever detect this kind of equally accelerated field? What do you think? And now we can do the same thing for these equally accelerative states. We can try to do an experiment and say, okay, let's say we're convinced that mechanically there's no relative acceleration, and therefore we should identify this state as inertial, even though it's supposedly accelerated. But maybe if we turn on some device, there would be a difference. Now we have a more sophisticated version of that, and we can see that even if you have accelerated objects, if they're all accelerated in exactly the same way in any given region, if it seems exactly inertial according to every measurement we can make, then we identify it as in fact inertial. In the case of this equally accelerated force, if you don't resist the force, and you're accelerated along with the field, and everything is not resisting, and so everything is accelerated. And if something is resisting the field, well, you can point to them and say, well, you're resisting, you're doing something, it's you that's not inertial, not me.
I mean, that sounds like gravity, effectively, right?
Good, that sounds like gravity. That's where we're headed.